All right, here we go with section 6, which is all about slope. This should be pretty easy. Hopefully you remember this from last year, and they covered this in depth in algebra. If not, then we're going to have to work together a little bit more. So the slope of a line is defined by an equation. If you have the endpoints of your line segment, or just 2 points on any line with the coordinates x1, y1, and then x2 and y2, you can plug those coordinates into this slope formula, which is y2 minus y1 over x2 minus x1. So what you're doing is you're subtracting the y coordinates and you're subtracting the x coordinates. So what's really happening is delta y over delta x. I don't know if you're familiar with that symbol. This is not like the triangle symbol that we've been doing all along with naming our triangles, but in the Greek letter delta, in math, that means change. So we're really talking about the change in y over the change in x. So it's like a ratio. And you guys are probably familiar with the term rise over run. And that's because rise is the up and down. You're going up, rising, right? So that's the y direction. And then run is like if you're running, you're going to run in this direction, and that's the x direction. So let's put this to use so we can get some practice. Calculate the slope of AB given the coordinates of A are -2, 5, and the coordinates of B are 3 and 9. So what we're going to do is we're going to take the y coordinates, 9 and 5, and we're going to subtract them. And you kind of have to decide which order do you want to subtract. Do you want to do 5 minus 9, or do you want to do 9 minus 5? And whatever order you decide to do for the y's, you have to keep that same order for the x's. So I'm going to do 9 minus the 5. And that means that down below for the x's, I have to start over here with the 3 and subtract a -2. And anytime there's negatives in our coordinates, we have to be really careful. So this is subtracting a negative, which means we're ultimately going to be adding those numbers together. So to simplify this, 9 minus 5 becomes the 4, and the 3 minus a -2 becomes a 5. So the slope of line AB is 4/5. Okay, so just be really careful. A lot of mistakes that can be made here. First of all, people will try to subtract the x coordinates and put them over the y coordinates. So they'll do the x over y. So that's a common mistake. Another mistake is getting the order wrong. So like they would do 9 minus 5, and then by mistake they would do -2 minus 3. Another mistake is some people actually subtract the x and y coordinates. So they would do -2 minus 5 and then 3 minus 9, which you definitely don't want to do. And then the last thing that I have seen is getting the slope formula mixed up with your midpoint formula and people adding instead of subtracting. So really, really watch out. Make sure that you know this formula backwards and forwards and you know how to use it, plugging in the coordinates in the right place. Okay, so next what we're going to do is take a look at some different slopes of lines and classify them. So the first one we're going to look at is the slope of a line that is kind of going up to the right. So if you see that it's going up to the right here, that is designated as a positive slope. So if you were to calculate that out, your answer would be positive. The next one is a negative slope. So now our line is going up to the left. So if you think about the right side being positive, left side being negative, that kind of tells you, looking at the direction that it's going up to the left, so it's a negative slope. So had we picked 2 points on this line and plugged them in, our answer would come out to be negative. The next one is zero slope, and that is the slope of a line that is horizontal. So something that's completely flat. And if you think of slope and equate it as how steep your line is, well, if your line is completely flat, it has no steepness whatsoever. So it has a zero slope. Okay, and if we were to pick 2 coordinates 2 points on these on this line and we plugged it in, what you would notice is that the y coordinates are the same. So like say this is going through the point 2 up here. So the y coordinate for a point over here would be 2 and the y coordinate over there would be 2. So if you're plugging it in here, 2 minus 2, you're going to get 0. So 0 divided by a number is 0. Now, the last one is the vertical line. And that actually has an undefined slope. And perhaps last year they talked about that as being no slope, but we don't like to use the word no slope because no and 0 kind of get mixed up with people. So we call this undefined, and it's truly undefined because in this case the x coordinates are the same for your 2 points, and if you plug in the same thing here, say 5 minus 5, you end up getting a 0 in your denominator. And anytime you divide by 0, you get an undefined answer. So that's why the slope is considered undefined. Okay, so moving on. We have theorems 26 and 27 that talk about the parallel lines and how their slopes are related. And what they say is that if you have 2 parallel lines, then you know that their slopes are the same. They are equal. So the slope of line A is going to equal the slope of line B. Okay, so that's very useful. So maybe they've given you the slope of line A and you needed to figure out the slope of line B. You don't have to do any calculations, you just know it's the exact same thing. Okay, you can also determine if lines are parallel based off of just looking at their slopes. So if you calculate slopes and then you see that they're both the same, then you would be able to classify line A being parallel with line B. Theorems 28 and 29 deal with perpendicular lines and their slopes. And the interesting thing about perpendicular lines is that their slopes are opposite reciprocals of each other. So here's my example. Line A is perpendicular to line B, which we can see by our little right angle mark there. And say we were able to use our formula and calculate the slope of line A, and it came out to be 2/5. So that's this line right here, 2/5. So if we wanted to figure out the slope of line B, all we have to do is take this fraction, make it the opposite sign, so since it's positive, it's going to turn negative, and we have to take the reciprocal, which means we're going to flip it upside down. So the 5 is going to move up top and the 2 is going to move down below. So the slope of line B is going to be a -5/2. Okay, so there you have it, parallel lines, perpendicular lines, and of course our handy-dandy slope formula. Okay, hopefully that wasn't too bad, and that was a good way of finishing off our chapter, and I will see you guys later.